chapter are we on?
8.
That's what I thought.
Chapter 8.
Okay.
Yeah,
Thanks.
Geometry, Chapter 8. And here, that becomes rather obvious. Now, you can see there's normally, what, 8 lessons in the chapter? Because of our schedule and abbreviated, we're going to get down to there. 1, 8.2, and 8.3. So the plan is tonight, I'll do 8.1, and when we get on Thursday night, I'll do 8.2 and 8.3, and the rest of Thursday, we will review for the exam. Then, exam review will be continued on Sunday night, and on the week 10, I will still take some questions at the beginning. But we do have to leave a little. The exam will be longer than the chapter test, so we'll need to leave time. But we can ask and answer questions even on week 10. Okay, so 8.1 is mostly going to be terms. So I'm going to be real heavy on terms here. You can get most of these in the book. There are just a couple terms in Chapter 8 that take on a little bit different approach than maybe what you had when you last had this in high school. I will point those out specially to you. So, to introduce the topic of geometry, I just want to make this point. Geometry is by far the oldest math book around. Well, one of the oldest. I mean, this book, basically, the book Geometry was based on was written 300 years before Christ. Geometry has not changed a bit. Very historical. The guy that wrote it is named Euclid. You don't have to remember these dates. Don't write this down. I just thought this would be interesting.
I had to walk away from it. You said it's being recorded, though?
I did start recording, yes. Thank you for the reminder. I appreciate that. So anyway, we're just going through a little bit of history here. You do not have to remember this, okay? Geometry was written about 300 years before Christ. This is the guy, Euclid. You know, some basic things like this was the ancient level. It's just like an A-frame with a crossbar, and then they would hang a plumb bob from the top. And when the level, when the ground was level,
For 300 years
what?
old.
Were you asking a question?
No, I was telling my boyfriend come look at the level. Sorry,
Oh, okay. Well, that's cool. I mean, yeah. Anyway, this is the ancient level with a plumb bob on it, and the idea was you can't see it, but there was a mark in the center crossbar, and so whenever they were level, the string would go right through the center crossbar, and they would know they were level. And by the way, the pyramids were incredibly level. I'm sure they probably also used some water to help them do leveling, but anyway, the ancient level is a simple object based on this balanced symmetry. Here's a couple other ancient tools that they found when they were digging around in pyramids that were used, some of the early geometry tools. And then this is the building that we normally have class in from the air. And I just made if you look down here in the corner, in the bottom right corner, you can see I added some blue geometric marks. That's the building we're in, and you can see I mean, most buildings are largely geometric. That makes for easier construction. So anyway, a lot of geometry all around this. Okay, so let's get into terms now. I don't know if you remember this, but way back when you were probably a sophomore in high school, they had to start somewhere, and you had to start with some undefined terms, some terms we would just agree on. You know, words like straight. What in the world is? I know it's not crooked, but I mean, try to define straight, and it's not real easy to do. The three we agree on are, we're just gonna kind of agree on are the three terms point, line, and plane. And technically, a point is just a pinpoint location. In fact, it's ironic. As soon as I draw a point, it's already not a point, because a point really has no dimensions. I mean, we usually will make a dot so that we know we can see we're talking about a point, but technically a point has no dimensions. Of course, a line, we get into this concept of straightness, and we know that a line has no curvature to it. And then the last one is a two-dimension shape, like, let's say, the floor. The floor, even though it doesn't go on forever in all directions, is flat and is what we call a plane. And in fact, got any people who use tools? I'm sure you recognize there's a tool named a plane for making things flat. You know, like the top of a door. Maybe a plane is used to make it flat and to possibly shorten it a bit so it fits better. Anyway, point, line, and plane is kind of our beginning point. Okay, so we move on from there. And I got a ton of terms here. So, a line, we signify this way on the right here. If it's line AB, we draw the letters A and B, and we put a double-headed arrow on top. Why the double-headed arrow? Because the line goes on forever in both directions. Line A, so we read this right here as line AB. Line AB could be written or stated as line BA. So some of these you can do backwards and forwards, some of them you can't. Here, let's go down to the third one. You guys remember something called array? Array starts at an endpoint, E, and it goes on forever through another point forever. So it's got one end, and on the other end it goes on forever. That's array. And here's how we signify it. And we call that ray EF. This one you can't reverse. You can't call that ray FE. The first letter must be the end point. Kind of a weird one. You may not remember this one, possibly, I'm guessing, from high school. That's called a half line. So when the end point is what? Vacant or empty, and we call it a half line. So it starts after the end point. I know that sounds like a technicality, but that's called a half line. Just a little different from array. And here's the symbol, half line CD. Now a nice easy one, a line segment is just two endpoints with a straight line between them, segment GH, and that's exactly the same as segment HG. So this one, no problem reversing this one. I'm going to guess that probably except for the half line, most of these are pretty familiar to you. Maybe not. It's been a long time, right, since we've had geometry. Okay, now I need to, let me move this up, and I need to do a little erasing here. Get rid of this, and I'm going to do some erasing. Okay, so now, and this is, by the way, as long as we're on this, let me talk about when we get to an assignment on this one, The assignment is going to be in, you guys, for the most part, I'm not going to collect notebooks again. For those of you who want to do extra credit, yeah, you may want to, yeah, but otherwise, when I give an assignment today, you can pick out an array you want to do. You don't have to complete all of a certain number. But anyway, some of the important exercises on lesson 8.1 relate to this activity we're going to do here at the bottom. You see at the top we have this line which has the points A, B, C, D, and E on it up here at the top. And then over here on the left, let me change to red, and I'll do a little more erasing again. Okay, over here on the left, you can see we have geometry objects, and you recognize these symbols in between? That's intersection and union. So we're bringing back some symbols from our first chapter. Do you remember those? What was intersection? Where two sets overlap, what they have in common. And then when you have a union, like you have right here, union is when you take two and paste them together. So, can you take ray AC and paste it, and intersect it with ray CA? So here we go. I'm going to change to blue, and we're going to use this little work area on the right. Ray AC would look like this. AC and AC would look like that, correct? Ray AC starts on the endpoint A, goes through C, and goes on forever. Now, overlap that with ray CA. So right below it, I'm going to draw ray CA. Ray CA starts at C, goes through A, and continues forever. Now, I purposely put one under the other because if you squish them together vertically, where do they overlap? You know what I mean? If I push this line down and this line up, where would the two lines be together?
At A and C.
And everything in between, right?
Mm-hmm.
Yeah. And isn't that this?
Mm-hmm.
Okay, so does everybody see? So here, it's a little complicated. We're taking some basic geometry objects and we're putting them together with our set terminology. Okay, let's try another one. I'll leave that one up there. Let's do another down below. Let's do the second one here. Segment AB. I'll go back to blue again. Segment AB. Whoops, there's segment AB. And segment BD. Whoops, what happened to my B? And segment BD. So here's segment AB. Here's segment BD. What happens if you unite them? So this time, squish them, squish this one down and this one up. And paste them together, and what do you get?
A through D.
You get the longer segment AD. Okay, are you seeing how we do this? Let me make some space, and let's do the third one. Okay, the third one, segment AB. Too many colors here. Segment AB. And now I want to overlap that with ray BD. Here's ray, whoops, getting some interesting erasures here. There's ray BD. Where do they overlap if you squish them together?
At B.
Only at point B, so that would be our answer. And let's do the last one. Segment AC, so let me go back to blue. Okay, AC. Some of you maybe don't even see what I'm doing. I hope you do. Segment AC and ray BD. Ray BD. And this time we're doing a union. So if you squish these together and paste them together, what do you get?
AD gone forever.
Yeah, by the way, what else could I call this?
ABD. ABCD.
Well, you don't want to use more than 2 letters, but you could say ray AB. That's the same thing, isn't it?
Right.
Ray AC, ray AD, ray AE. Actually, those are all correct answers for this, right? Because they're all names for the same ray. Hopefully, I'm hearing. I'm definitely hearing Lisa, but I'm hoping the rest of you are with us too. Okay, move on. So you're going to see some assignment questions that are of this type. And I kind of like this idea of drawing the master line and sketching it below. And think of, in your mind, of squishing them together vertically, I think. And then either what? If it's an intersection, where do they overlap? And if it's a union, paste them together. Okay, next slide. All right, just a tiny bit of algebra. Does anybody remember what do we call it when 2 angles add up to 180 degrees? This is maybe unfair because you guys haven't had geometry for a long time. Does anybody remember that? Starts with an S. SU. Does anybody remember that? Angles are supplementary? I guess not. Okay, well anyway, if 2 angles add up to 180, and then what if angles C plus B also equal to 180? Could I actually do this kind of math? Okay, let me tell you what's going on here. I subtracted, you see I have an equation on the top, and then I have another one in the second row. I subtracted the bottom equation from the top one. Okay, what's A minus C? Well, it's A minus C. What's B minus B? Well, that's going to go away, right? Because B minus B is nothing. And what's 180 minus 180? Nothing. So the B's are gone, the 180s are gone, and that leaves me with this. Well, if A subtracts C is nothing, doesn't that mean A and C are the same? So there's a little tiny bit of algebra type reasoning there. It's okay to add equations to equations and subtract equations from equations. You'll see a little, we'll do more, and you'll see some good examples in the book too. Okay, let's keep moving here. Next term. 2 lines are parallel. You already saw that maybe in the humorous introduction. Parallel lines never meet because they're always the same distance apart. This is the symbol for that. This reads line AB is parallel to line CD. So this little slanted 2 lines like that is the symbol for is parallel to. Okay, I'm sure everybody, this is called an angle. 2 rays that start at the same endpoint. Now, whenever you name an angle, you want to use 3 letters, and you have to have the vertex, that is the where the where the turn takes place. In this case, E. That letter has to be in the center. So you can either call it angle FEG or angle GE. The E has to be in the center. Should have brought some water in here. Okay, so an angle, I'm sure everybody knows what an angle is. But anyway, what I want to remind you is you want to name them with 3 letters. And put the corner of the angle, the vertex of the angle, in the middle. Either of these is correct. By the way, just a little irritation thing. When you have this E is called a vertex, and when you have more than one of them, they're not called vertexes. They're called vertices. So, kind of a little piece of trivia, but it's kind of important. Okay, so let me erase here. When 2 lines cross, like you see in this picture, we have some equal angles that are formed. You should be able to see that angle 1 is the same as angle 2 in size. We call those vertical angles because they're on the opposite sides of the vertex. There's that vertex again. There's another pair of vertical angles. Angles 3 and 4 are also vertical angles, and they too are the same. So 1 and 2 are equal, 3 and 4 are equal. They're 1 and 2 are called vertical angles, 3 and 4 are called vertical angles. Can anybody tell me what are angles 1 and 3 together?
Are you talking like a 40?
Yeah, not a number, a word. What do we call angles 1 and 3 when they make a straight line when you put them together? I'll give you a clue. It was on this page, and I wrote it on there. Supplementary.
Yeah.
Yeah. Okay. Again, unfair. I'm just trying to jog your memories a little bit. Yeah. Here you can see it. 2 angles together that make a straight line are called supplementary. And when the 2 angles together make a straight corner, a right angle, we call those 2 angles complementary. So when they make a straight line, supplementary. When they make a right angle, complementary. Okay, I got one more term on this page I want to show you. And for this one, I had to make like a sketch of a 3D object, now, which is a little bit unfair because you're looking at a 2D screen, flat screen. But can you see that I'm trying to draw a cube here? Does anybody see a cube at the bottom of the page?
Yeah, I do.
One person sees a cube.
Maybe I'm the only one.
I see it too.
Okay, good. I'm just checking if your pulse, if you guys are still alive, because otherwise I have to send the EMTs. Okay. Now, here's a term I'm almost positive you didn't have in high school. Okay? Do all of you see the side of the cube, that segment CCG? You see that right back there in the back, segment CG?
Yes, I see it.
Okay. And then look at this segment, EF. All right. Now, do you see? I mean, if you're looking at it the way I'm looking at it, CG is part of the back of the cube, and EF is part of the front of the cube. Is that the way you're seeing it? Because you can see it the other way, too. I'm hearing sound, but it doesn't. But it sounds like it's restaurant sound. Does anybody get what I'm talking about? In this cube, part of the cube is closer to us, and part of it's farther away. The way I'm seeing it at the moment, CG is in the back part of the cube.
I have a question.
Yeah, go
Why?
ahead.
Why do you have two B's on there?
I
Or is
don't.
that
There must.
Oh, forget it. I don't have my glasses on. It's an E, Ron.
Yeah. Okay. I'm sorry. That's not very clear. But you're talking about that top right one. That's an E. Yeah.
Yeah, sorry.
No, it's all right. So CG is kind of in the back of the cube, and does everybody see that EF is in the front?
Yes, I see it.
CG and EF are called skew lines. And here's why. They're not parallel, but they will never intersect.
Right.
Now, if we were in the classroom, I could show you with edges, but I can't. Can you guys see that those two lines, if I extended them, would never cross each other? You guys have to think in 3 dimensions in order to see this.
Yeah, I noticed that they'll never intersect.
Right. I got it.
All right. But would you agree they're not parallel? Because parallel lines always stay the same distance apart, right?
Right.
And those two lines sure don't stay. I mean, they're all over the place. One goes horizontally, one goes vertically. They're not parallel. Anyway, those are called skew lines. And here's the term over here. You probably, I'm guessing, never dealt that in your previous geometry class. Okay? I need you to know those by name and be able to identify them. We're almost done, guys. All right, let's just a couple more. We actually have there are special kinds of angles. If the angle itself makes 180 degrees or a straight line, like angle DAB does in this picture, that's called a straight angle. And if the angle, let me make a picture. If the angle makes a 90-degree angle like this, then it's called a right angle. If it's an acute angle, that just means that the angle is less than 90 degrees. And here is let me change my color. This guy over here is obtuse. Obtuse just means it's more than 90-degree angle spread apart. It's less than 180, but it's greater than 90. If we do a kind of a capital T symbol, that means the same as the right angle. That means, it's like in basketball or football, the old timeout signal. One hand horizontally with a vertical line making a T, timeout. Well, upside down or right side up, it doesn't matter. We call that means perpendicular. So we have the same situation we had up here where we called it a right angle. I'm going to skip the intersects, not very important. And then just to bring back some theorems from the old days, we already did this one. Do you remember a few minutes ago? The one in the top left? What do we call angles A and B? I know they're equal, but what do we call them?
Supplement?
No.
No.
A and C would be supplements, but what about A and B? Anybody remember? It's all right. I just gave it to you tonight.
Vertical angles.
Vertical angle?
That's the one. Very good. Those are vertical angles. Very good. Here's one you probably do remember from geometry class. I don't know. Maybe you do. Maybe you don't. But I don't care what shape the triangle is. the three angles always add up to 180 degrees. And then at the bottom of the page, we have line, I'll just call it line A and line B. A is parallel to B. And this line that's crossing them, not important, we call that a transversal. Can you see some angles that are equal here? I don't know, maybe you can't see the letters, they're maybe too tiny. Cindy, still got your glasses on?
No, I don't, but I can see them, thank you. But the pictures, our pictures are in the way, either pull up the...
I turned them off.
Oh, I can...
Oh, okay. Anyway,
Okay.
Does that help?
Yep.
Yep, we don't want them covered up. Thanks.
Mhm.
So anyway, if you look on this page, can you see of all those letters some angles that the angles look the same size?
Oh, yeah.
Okay, just give me a pair.
Like, do you mean the same size, like, A, well,
Like
B and
what's the
C,
same? What? Okay, go ahead.
B and C are the same.
That's correct. Okay, let me circle
A and
those.
D.
What'd you say? A and D?
Yep. And then
Yep,
the
that's
same
correct.
on the bottom.
Yeah, and there's even more. A is also the same as G. Anyway, that's just a reminder. There's a whole chapter of. If you look in the book, you'll see there's all kinds of reminders of some of these. Well, you can see they're written on the bottom here. Which ones are equal? And you don't have to remember these names. This alternate interiors, alternate exteriors, but you should see which ones look equal. Yeah, when I get back with you guys, I don't know, we may have time, we might do a little exploration in the pyramids. That's what this last slide shows. And then, like I told you, this is not really an assignment, okay? But these are the ones I would have assigned. So what I would ask you to do is go into lesson 8.1 and just go through some of the problems in those two sections. You notice I have skipped numbers 15 through 27. So don't do any between there.
Can you scroll up, Ron?
I can't scroll up any further.
How do I get rid of the people's pictures?
I already did, but okay.
I see everybody on mine.
All right. Take your mouse. You have a mouse?
Yep.
Okay. Go on your screen and move up toward the top. Do you have a black shield that comes down?
Well, that has like the camera and stuff in it, you mean?
Yeah.
Hide
Yeah.
participants.
Okay. Go to the symbol way on the far left.
Yep, I just did it. Thank you.
Okay. Good. So I guess each person has to do that. I didn't know that. All right.
So since you
let
said
me-
we're not, oh sorry.
Okay. Try that out. I only got part of that.
So since we're not turning in our notebooks again, is the only other grade we're going to have in our grade book now just the final exam and extra credit?
That's correct. But I mean, it's not a big deal because you see, I don't like a lot of professors will grade on points, and then I know what you think is I need more points. I don't grade on points. I grade on. I have a notebook average, I have a test average, and then I have the exam. So you guys already, if you already have a good notebook average, you're not losing out by not having a third notebook. You follow me?
Yeah, gotcha.
So it's not like you're being deprived or anything here. It's not going to hurt you at all. Your notebooks, you guys just about all of you have really good notebook averages, so you're in pretty good shape there. So let me repeat. Let me just finish a little bit more, and then you can ask more questions, okay? So when you do this assignment, you don't have to do them all. Just do some of the 1 through 15 odds and do some of the 27 to 65, just enough that you think you know what they're trying to get you to do. And do the odds so that you can check them in the back. So you're doing them just to get yourself prepared, not for me to look at them this time. Okay, now what was the question you were asking?
I guess I can ask it on an individual basis.
Actually, I think it would be a good question. You can let her rip.
If, let's say someone had a good notebook test or notebook grade, but they struggled in the exam and the test, could they still technically pass the course, or you kind of need to do okay in every area?
Well, take a look at what's happened so far. What would be your judgment so far? I mean,
yeah, I guess that scares me though, because the final exam.
The notebook can have a huge. I mean, the notebook doesn't count quite as much as the test, but still, the notebook has a very soothing effect on rough test grades. So the answer to your question is yes, it is possible.
Okay.
And in fact, some of you just your grades now, you would see the answer to your question. Because there are a couple people who have struggled with the test, but still their grade looks pretty decent. Why is that? Because of the notebook and because of extra credit. So it's possible, but if you're sensing there is no buffer for the exam, you are correct. There isn't. But, I mean, college classes end with exams. It's kind of a fact of life. But still, what is the exam? I think the exam is 30% of the grade, the same as tests. So anyway, I'll elaborate more maybe when we get together, but it should be obvious already that test grades are not they're the biggest factor, but boy, there's a lot going into the notebook grade and a lot going into the extra credit, and some of you have seen your grade get buffered greatly as a result. I like that because it seems to reward hard work, and that's what I was kind of preaching to you guys.
Thank you.
Yeah, you're welcome. It's a good question. So actually, that's going to be the end of the lesson tonight. But I maybe have gone too quickly. Any part of the lesson you want to go back over? So we didn't really do anything real technical. We brought back a lot of terms, some diagrams, some labeling. We had to play around with a little bit of intersection and union again. So get in there, mix it up with some of the assignments, and start getting familiar with these terms. I would say Chapter 8, probably the biggest part of it is terminology. Otherwise, anybody? Question? So then, when you all right, when I stop the recording, just thanks to those who reminded me, you should have a recording of lesson 8.1. If you do want to go over the test anymore, let's just do that when we get together on Thursday. Or you can write me personally, call me. All right, I think that's it for tonight. Thank you all.
Thanks, Ron.
Thank you.
Sorry I pressed you guys with a bunch of questions tonight. Lisa, I hope your pizza is good. I'm sorry if we kept you from having supper.
No, it's okay. I just work on Sundays every other, so it's tough because you gotta do a marathon and try to eat and all that stuff. So,
And
but
class.
way to work.
Yeah. Well, thanks for your effort. Okay, everyone. Thank you. Good evening.
Bye.
Bye.
Bye-bye.